So I'm here with the Tektronix 2247A, and everything on this unit works perfectly fine except the three pots up here to adjust the A, B, and readout intensity. Yes, the scope's upside down because I got the cabinet open so I could access the main board, but as you could see when I rotate the A intensity pot, there is no change at all. And the B does the same thing. And readout is sort of interesting because if I go fully counterclockwise, it cuts out. And then if I go back, it turns back on. But there's no change or modulation in the intensity. So there's clearly something going on here in the circuitry. So I've already done most of the work here in trying to route out the problem, and the first thing you do is check the voltages, and you could do that. Let me just get this over here quickly. The unit's on. I don't want to get zapped by the 2.7 kV, so there we go. And I actually have my camera mounted on this wafer box, and yes, there are 6-inch silicon wafers inside with some CMOS devices that I fabricated back at my undergrad, but those days are over with. Anyways, so I checked the voltages here at jumper 1204, and they all check out fine. You could look in the service manual. And so the next item is to pull up the schematics to see where exactly the problem is. And the key schematic that we're going to look at is the Z-axis, CRT, probe adjust, etc. This is diagram 7 of the service manual, and this is very similar for the 2245 and the 2246 models. And so it's very nice. Let me try to get this down here, because it gives you voltage references and biasing on what they should be. And so I've gone ahead and started over here from the A intensity pot, and I've just gone through and recorded the voltages. And what the 2247A does with the intensity control is it's not entirely analog. It's digitally processed, and it's also multiplexed using, well, in a combination of the IC U1001 and what's the other one here? U506. Where is it? Way up here. U506 does multiplexing. But there are several other components of the scope that rely on these parts, and everything else works fine. So for that reason, I would rule out the digital side as being a problem. And you could also do a what's called an exercise pots test within the service menu of this scope, and those checked out perfectly fine. So as I've gone ahead here and probed all of these points throughout the board, and just to point out, here's a printed out, blown up view of the board directly underneath it. But here's the three pots are located over here, and here's U506, the multiplexing chip, and the processing also branches off to the DAC board, the DAC subsystem board, which is located right there. But I don't think that's an issue here. And so if we go over here to the schematic, here is IC U1001. All that is an LM324. And surrounding it we have the important components that we need to look at. So back to the schematic. Here's a blown up portion right here, since we don't need to look at everything else of the schematic. I've cut off the area where there's U1001 and it continues through here, and I've checked all the voltages, and all the voltages check fine. But when we get to this region up at Q2707, I forget what that is, it's some NPN, but anyway, it should be reading 10.7 volts at the collector, but it's not. It's very low. And if we continue through, well, we have transistor 2705. This voltage checks fine, 15 volts at the collector. The emitter is measuring 5.27. We continue over here, and it's problematic. We're measuring 99.2 volts here, which we should be from this resistor divider network. This is a transimpedance amplifier. I've been getting some help from David from the Yahoo group TekScopes. He's very helpful, and I recommend that anybody with a vintage TekScope or any Tektronix equipment subscribe to this Yahoo group. They're very helpful and insightful. So thank you, David, for helping out here. So this region here, as David mentioned, this is a transimpedance amplifier, and this converts the current input, which is on this side, to a voltage output. And the output of this voltage should be reading in the range of 14.7 to about 40 volts. That's clearly not the case. We're measuring somewhere around 7 volts, so something's going on here. And I would say something has blown, possibly in this region right here. This is the Z-axis region. So we've pretty much eliminated most of the scope to this handful of components here, which is nice, because there's a lot of components there, and we don't want to be looking at everything. So, back to the schematic. What's going on here, we have 130 volts here and 99.2 volts here. We have this 5.6K resistor, R2717. So we should be getting about 5.5 milliamps of current flow through this current meter here. But that's not the case. We're not getting this current, because we should be reading a higher voltage out here if we had that current drive. A component of that current would flow back up here through this, I don't know if it's a feedback that's going on here, but it branches back to the input. And this would keep the input high, around 10.7, but it's not. It's too low, so the input's dropping. It's not maintaining this constant voltage it should be. Just looking at the board, usually if you see a bad resistor, you can see it's burnt or something. Try not to drop my phone on the high voltage region. The scope is still on. I should probably turn it off. Yeah, let's go ahead and turn it off. Watch neon bulbs light up. So here's U1001 right there. And to the northeast of it, we have what's Q, I think this is, just to make sure, yep, this is Q2701, Q2702, and this is 3, and then 4 is at the top. So what David and I have speculated that it's possible Q2704, the NPN here, is possibly shorting to ground. Now this transistor, and that one, these are all in forward active mode. So if this one is shorting out, this could be problematic in a sense. This negative 0.8 drop here is most likely due to just the drop from this diode here, which is just flowing out through our 2710. David also pointed that out on the TekScopes forum. So what I have is a spare part here, and Q2704 happens to be 2N4401 NPN. So I'm going to desolder this because right now we've narrowed it down to this small region here of components, and nothing visually looks bad, so we have to start checking parts here. We've measured voltages. It checks good up here. It checks good over here up until this point, and the output's dropped. So it's likely something going on with this amplifying stage here. So I'm going to go ahead and turn on got my trusty old Weller over there. And I'm not going to take this main board out. What I could do is I could use my hot air station and just pull Q2704 right out. But I think Tektronix during assembly placed the components and they bent the leads on the underside. So I'm going to have to wiggle this thing. So I'm going to go ahead and unplug a scope here. And we could likely get started. I got enough light. I'm going to go ahead and add a little bit of flux to a little bit. This is Amtech 4300. It's lead free and leaded compatible, which is nice. So I'll go ahead and add a tad bit here. Should be enough. We can clean it up afterwards. Tweezers. I think that's a good enough shot. Go ahead and turn the station on here. This is a Heiko 850. I picked this guy up on eBay for like $100-something. These things are awesome. Thinking I could go with a bigger pair of tweezers. Now it's definitely bad. This is a real pain to get out. I should probably just clip the leads. Here we go. So the emitter was on the far side, okay. Also may have found another problem. So that's interesting. This capacitor here, under heat, now I was hardly touching this capacitor. I was on lowest setting I could with full airflow. And this thing the lead kind of moved right out of the capacitor. That is interesting. This is, like, let's see here. This is, we're up here. It's a resistor. C2703. Is that the one? Yeah. So C2703 needs replacement. That's interesting. Here's this guy here I pulled out, the transistor. It may still be able to test in the curve tracer. Where are you? The top is off, but the die is still in there. Well, we could always plug it in and test it. We don't need the Weller. Wow, that is... I can't believe that. Before I had even reached the wetting point of this solder, this lead just popped. I don't know if you can see it here. There's the capacitor. This lead just popped right out of the capacitor. It's gone. Look at this. So that's got to come out. Everything else looks fine. Okay. On with the test of the curve tracer. So we're going old school. This is my Tech 577. This is my baby. So right now I got just a standard NPN in it. So let's do a quick test of it. Let's put it on 100 volt max sweep. We're going to be doing 10 microamp steps on the base, and we're going to do 10 of those steps. And we could sweep this isn't a really high voltage NPN, so we'll just go 5 volts per division and 2 milliamp per division on the current, vertical current scale. And we enable it with the left switch here. This is like a blast shield. If you lift it up, it's got a safety mechanism, so it disables the output. And here we go. Voila. Beautiful. We get a little breakdown over here. Yeah. So we're ready. Put that in the center. We're going to plug in the... Where is it? Emitter... base collector. This probably won't work. so we could try it. There's no way it's gonna work. Which kind of sucks, because now I don't know if this was really the problem or not. Let me bend the leads a little bit. That capacitor, though, that was definitely an issue. The little ceramic capacitor, probably like, I don't know, 22 picofarads or something. The leads are all bent so it doesn't go in the test template very well. I don't even know if that's in all the way. That's what she said. Okay. Well, I could try it. Regardless, the thing's shot. This is an NPN device. Oh, this thing is shot. Look at that. Wow. I got a connected emitter base collector. Yeah, this thing is just... Look, now it's open. I probably just knocked it. Wow. Let's go down to a lower bias. I can't believe this. It's shot. I'm wiggling it and it's just... Oh, here we go. Go to a higher range. But, okay. Okay, we're going to have to replace that one. So with that being said, we'll have to stop this video and continue with a part 2 until I at least get this replacement capacitor. I do have a replacement NPN for that, but this capacitor I have to order. So until next time.